Users of mobile phones and other wireless devices are always looking for longer battery life. Measuring your mobile device's overall power consumption is useful for optimizing battery runtime, but you also need to measure and analyze your device's subcircuits. Some examples of important subcircuits include display illumination power controls, baseband microcontrollers for voltage frequency scaling, RF power amplifiers when dynamic voltage control is used. All the various subcircuits are usually powered by a power management unit. The PMU provides independent, regulated bias voltages to each of the subcircuits. In this case, it is usually necessary to measure the respective voltage and current powering each subcircuit instead of directly powering it with an external DC source. Here is a setup using conventional data acquisition equipment for measuring a battery input at the same time as the subcircuit voltage and current. High-speed digitizing of the current is essential, as it provides many detailed insights about activities. Individual subcircuits often have much lower minimum currents, and therefore may need even greater dynamic measurement range than the overall device needs. The wide-ranging current drain usually exceeds the instrumentation's dynamic measurement range, limiting achievable accuracy. This becomes even more of a problem when you consider that the current shunt peak voltage drop should be kept below 50 millivolts, so it does not affect the subcircuit operation and test results. Conventional data acquisition equipment usually falls short of providing sufficient gain, dynamic range, and accuracy for good results. Additional independent measurement channels are also needed to log the battery and subcircuit voltages simultaneously with their currents. They provide the key insights necessary for analyzing the battery input, subcircuits, and PMU control activities of your device. There is a better measurement solution from Agilent Technologies for making these challenging measurements. The Agilent N6781A source measure unit installed in an N6705B mainframe has specialized features for testing battery-powered mobile devices. Here you see a test setup using two Agilent N6781A units to test a GPS device. One of the units was connected to provide a battery input, and the other was used to measure the RF amplifier subcircuit voltage and current. The N6781A has a number of unique features that provide improved accuracy for this type of testing. The battery emulation source has realistic input power characteristics and more accurate results. The zero-burden shunt operating mode eliminates the voltage drop problem of conventional shunts. An independent DVM input is provided for logging the subcircuit bias voltage. Seamless measurement ranging provides accurate current measurement of signal levels spanning from sub-microamps to amps in one continuous logging measurement. High-speed, high-resolution waveform capture and data logging capabilities assure accurate measurements for most pulsed signals you are likely to encounter. In this example, we measured the input power demands and turn-on timing of the RF amplifier in a GPS device. To conserve power, the PMU should power up subcircuits only as needed. The test results, captured and displayed using the Agilent 14585A control and analysis software, are shown here. Findings include the battery input drew average and peak currents of 0.290 amps and 0.822 amps respectively. The PMU powered up the RF amplifier at the desired point of operation, as required. As you can see, evaluating subcircuits with this Agilent system configuration is a powerful way to gain key insights for optimizing your mobile device's battery runtime. For more information, visit the Agilent website at www.agilent.com/find/N6781.